Hello students, today we are going to discuss the numericals of exercise 2b, which is based on graph. Come to question number 1, where two graphs are given, where first graph is the displacement time graph and second graph is velocity time graph, which we have to draw based on displacement time graph. And the question asks, find the velocity when t is 1 second, 2 second and 3 second. So when t is 1 second, from the graph you can see that this displacement is 2 meter, that is s is equal to 2 meter. So velocity is displacement by time, which is s by t, which is equal to 2 by 1 equal to 2 meter per second. When t is equal to 2 second, you can find that displacement is equal to 4 meter. So velocity is equal to 4 by 2, which is equal to again 2 meter per second. When t is equal to 3 second, s is equal to 6 meter. So velocity is equal to here 6 by 3, which is equal to 2 meter per second. It means that the body is moving with uniform velocity 2 meter per second. So if you will draw the graph of this, the second graph, it will be line parallel to time axis where velocity is equal to 2 meter per second. So as you can see that in the graph I have drawn a red line, that is the graph for second part. Come to question number 2, where it asks that one table is given for the displacement of a car at different instants of time. You have to draw a displacement time sketch and find the average velocity of the car. The second part is what will be the displacement of car at 2.5 second and 4.5 second. So as you can see, I have drawn the graph for you where I have taken, you have to keep always time on x-axis and displacement on y-axis. As time is given 1 second, 2 second, 3 second, 4 second, 5 second, I have taken a scale here 1 centimeter as 1 second, and here on the y-axis I have taken 1 centimeter as 5 meter. So here you have to always keep it in mind that whenever you will draw the graph on any axis, the interval must be equal. That means here I have started from 0, then 5, then 10, 15, 20 and 25. Accordingly, what was the displacement at 1 second, what was the displacement at 2 second, what was the displacement at 3 second, accordingly you will plot the points. So I have plotted the points A, B, C and D from the given information. So here you will find that average velocity of the car is 5 meter per second, and using graph if you will find the displacement of the car at 2.5 second, it will be 12.5 meter. Similarly, displacement of the car at 4.5 second is equal to 22.5 meter. Come to question number 3, where again table is given for the displacement for the different time. Here also you have to plot the displacement time graph, and then you have to find the total distance traveled interval 1 second to 5 second and average velocity in the time interval 1 second to 5 second. It is based on the previous question. Both are almost the same, and leaving explanation for this question. You can see the graph as well as the answer for different questions. Now come to question number 4. So question number 4, graph is already given, and based on the graph you have to calculate the velocity of body as it moves for time interval 0 to 5 second, 5 second to 7 second and 7 second to 9 second. So for time interval 0 second to 5 second, displacement is 3 meter and time taken is 5 second. So velocity is again displacement by time, which is equal to 3 by 5 equal to 0.6 meter per second. For time interval 5 second to 7 second, displacement is equal to 0 meter, time is equal to 2 second. So velocity will be 0 by 2, which is equal to 0 meter per second. For time interval 7 second to 9 second, displacement is 7 minus 3, which is equal to 4 meter, time is equal to 2 second. So velocity is equal to 4 by 2, which is equal to again 2 meter per second. B part is for time interval 5 second to 9 second, displacement will be 7 minus 3, which is equal to 4 meter, time is 4 seconds, so velocity will be displacement by time, that is 4 by 4 equal to 1 meter per second. Come to question number 5. Here, from displacement time graph of a cyclist given in figure 2.39, find the average velocity in first 4 seconds, displacement from the initial position at the end of 10 seconds, and the time after which he reaches the starting point. So here you can find the displacement in first 4 seconds is 10 meter. Time taken obviously 4 seconds. So average velocity will be displacement by time, which is equal to 10 by 4 equal to 2.5 meter per second. Now displacement from the initial position at the end of 10 seconds, you can see in the graph that it is towards the negative side, so it will be minus 10 meter. Time after which he reached the starting point, you can see that the graph has touched the 0 mark, that means x-axis, twice, once at 7 seconds and once at 13 seconds. So once we will go towards any direction and we consider it as a positive direction, if we will go opposite direction of that reference point, that is considered to be negative. Come to question number 6, where it shows us the distance by which the car B was initially ahead of car A. So you can see in the graph that B is 40 km ahead of car A. Now for car A, displacement is 160 km, and for that it has taken 4 hours. So velocity of car A will be 160 by 4, which is equal to 40 km per hour. For car B, displacement is 120 minus 40, because total displacement when he reached after 4 seconds it is 120, but it started at 40 km. Already it has a displacement of 40 km. So total displacement will be 120 minus 40 equal to 80 km. Time taken 4 hours. So velocity will be displacement by time, which is equal to 80 by 4, which is equal to 20 km per hour. So time in which car A catches the car B, from the graph you can see that when time is 2 hours, both the graphs intersect each other. It means that the KA will catch the car B after 2 hours. The distance from the start when the car A will catch the car B is equal to 80 km. From the, if you will see on the displacement graph, displacement axis, they intersect at the intersection point at 80 km. Come to the next question, question number 7. Here informations are given, different displacement at different time is given. Based on that we have to plot the graph. So graph is already plotted, and you can see that the graph is not a straight line, it is a curved line. Because of this, the motion is non-uniform, it is an accelerated motion. So I have taken here the time on x-axis and displacement on y-axis, and whatever displacement is given with respective time, accordingly you will plot the point. If you will join it, it will give this kind of curve. Come to question number 8. Here in question number 8, two graphs are given. So first graph, based on the first graph you have to find the displacement, and then accordingly you have to plot the second graph. So since displacement is equal to velocity into time, and we know that it is area enclosed between the velocity time sketch and x-axis. So at t equal to 1 second, velocity is 1 meter per second. So accordingly displacement will be equal to half into 1 into 1, because here the area enclosed by the graph and time axis is in a rectangle. So area of rectangle is half into base into height. So here it is half into 1 equal to 0.5 meter. At t equal to 2 second, velocity is 2 meter per second. So displacement will be equal to 1 by 2 into 2 into 2, which is equal to 2 meter. At t equal to 3 second, velocity equal to 3 meter per second. So displacement is equal to half into 3, which is equal to 4.5 meter. At t equal to 4 second, velocity is equal to 4 meter per second. So displacement is half into 4, which is equal to 8 meter. Based on that, at t equal to 1, t equal to 2, t equal to 3 and t equal to 4, whatever displacement we have got, accordingly you will plot the points. So you will find that it is an accelerated motion. Come to question number 9. Question number 9 says figure is given and accordingly you have to find some. State how is the distance traveled in any path determined from this graph. So we know that in velocity time graph, distance traveled in any part can be determined by finding the area enclosed by the graph in that part with the time axis. So there are three parts given, AB, BC and CD. So if you have to calculate the distance, then we have to find the area of graph enclosed by AB with time axis, then BC by time axis and CD by time axis. Second part is distance traveled in part BC. So here for our convenience I have given the points P and Q. So distance traveled by part BC is equal to area of BCQP, which is equal to T into V naught. Here total distance from A to Q is 2T and A to P is T. So if you will find the distance between PQ, it will be 2T minus T, it is T, and this vertical line, that is V0. Distance traveled in part AB, this is a triangle. So here area of triangle is, area of ABP is half into T into V0. So ratio between area of BCQP and area of ABP is equal to T into V naught divided by half into T into V naught. So if you will simplify, you will get 2:1. Now third part is which part of the graph shows motion with uniform velocity, uniform acceleration and uniform retardation. We know that if the line is parallel to time axis, it is uniform velocity. If it is inclined to the time axis in upward direction, then it is uniform acceleration, and if it is coming downwards, then it is called uniform retardation. So here uniform velocity will be the part BC, uniform acceleration is part AB and uniform retardation is part CD. Fourth is the magnitude of acceleration higher or lower than that of retardation? So magnitude of acceleration is lower as slope of line AB is less than that of line CD. So cause of this, the magnitude of acceleration is lower. Its fifth part is compare the magnitude of acceleration and retardation. So here acceleration equal to slope of line AB, which is equal to V0 by T, and retardation is equal to slope of line CD, which is equal to V0 by 0.5 T. So if you will find their ratio, you will get it 1:2. You can simplify this. Now come to question number 10, where velocity time graph is given and based on that we have to find the acceleration in parts AB, BC and CD. So here you can find that acceleration in part AB, acceleration is here the slope of line AB. Slope of line AB is here BP by AP. So here BP is 30, AP is 4. So 30 by 4 is which is equal to 7.5 meter per second square. Acceleration is part BC. You can find that there is no any change in velocity. So there is no any change in velocity. So it is 0 divided by time taken 4 seconds. So it will be 0 by 4 equal to 0 meter per second square. And acceleration in part CD, here the change in velocity is from 30 to 0. So it will be change in velocity is minus 30 and it has taken 2 seconds. So it will be minus 30 by 2, which is equal to minus 15 meter per second square. Second part is find the displacement in each part. So in velocity time graph, if you have to find the displacement, you have to find the area enclosed by the graph with the time axis. So displacement in part AB, area of ABP. Again I have plotted this point P and Q here for our convenience. So area of ABP is equal to half into 30 into 4, which is equal to 60 meter. Displacement in part BC is area of rectangle BCQP. So area of rectangle is again length into breadth. So 30 into 4, which is equal to 120 meter. And displacement in part CD is area of triangle CDQ, which is equal to half into 30 into 2, which is equal to 30 meter. So total displacement will be 60 plus 120 plus 30, which is equal to 210 meter. Come to question number 11. Question number 11 says a ball moves on a smooth floor in a straight line with a uniform velocity 10 meter per second for 6 seconds. At t equal to 6, the ball hits the wall and comes back along the same line to the starting point with the same speed. Draw the velocity time graph and use it to find the total distance traveled by ball and its displacement. So here the graph is already drawn, where 0 mark is in the middle and negative and positive displacement velocities has been taken on y-axis, and time is displayed on x-axis till 13 seconds. So in first second, when the velocity is positive, it will be towards the positive side where it goes in a particular direction, and after striking the wall, when it goes in opposite direction, so then at that time velocity will be negative. Since magnitude is the same, so we will keep the same, and since uniform velocity it is given, so you have to draw a line parallel to time axis. So initially at 10, line parallel to time axis till 6 seconds, and from 6 to 12 it will be parallel to time axis but in the negative side. So total distance traveled in this case will be area of triangle ABCO plus area of rectangle CDEF, which is equal to 10 into 6 plus 10 into 6, which is equal to 60 plus 60 equal to 120 meter. Displacement is equal to 0 meter. Since ball has returned back to its initial position, there is no any displacement. So there is no any displacement in this case. Come to question number 12, where a graph is given, and based on that we have to find the nature of motion of particle and displacement of particle at time 6, and few more questions. So first is the nature of motion is uniformly accelerated motion from 0 second to 4 second, and then uniformly retarded from 4 second to 6 second. As you can see that it is inclined, graph is inclined on time axis from 0 to upward direction till 4 second. After 4 second to 6 second it is coming downwards, so that is retardation. Second part is displacement at time equal to 6. At time equal to 6, in velocity time graph, if you have to find displacement, we have to find the area of the area enclosed by the graph and time axis. So here it is rectangle. So find the area of this rectangle. We will get half into base into height. So half, base is 6, height is 2. So half into 6 into 2 equal to 6 meter. Third is, does the particle change its direction of motion? Answer is no, because you can see that velocity time graph is always in the positive side. If graph we will get in the negative side, then we can say that particle has changed its direction of motion. Fourth is, compare the distance traveled by the particle from 0 to 4 second and from 4 second to 6 second. So distance traveled from 0 to 4 second is equal to half into 4 into 2, which is equal to 4 meter, and distance traveled from 4 second to 6 second is half into 2 into 2 equal to 2 meter. So if you will find their ratio, it will be 4 is to 2, that is equal to 2 is to 1. Fifth part is, find the acceleration from 0 to 4 second and retardation from 4 second to 6 second. So acceleration from 0 to 4 second, their velocity is 2 second, time taken is 4 second, velocity is 2 meter per second and time taken is 4 second. So acceleration will be 2 by 4, which is equal to 0.5 meter per second square. And acceleration from 4 second to 6 second, change in velocity is here minus 2 and time taken is 2 second. So minus 2 by 2 equal to minus 1 meter per second square. So retardation from 4 second to 6 second will be equal to 1 meter per second square. I hope this video will help you in solving the numericals. Thanks for watching.